Welcome. This video is on nonlinear functions. A nonlinear function is a function that is not a linear function. The graph of a linear function is a line. The graph of a nonlinear function is not a line. So nonlinear functions, basically we're just talking about graphs that are not lines, different curves. A linear function is of the form f of x equals ax plus b, where a and b are real numbers. Any function that has a different form would be nonlinear. So f of x equals ax plus b, that's kind of like y equals mx plus b. Remember, y is the same as f of x. And so instead of using m, we're using the notation a here instead of m. It still means the same thing. The number in front of the x is a slope when it's a line. Okay, so let's first talk about evaluating functions. Evaluating functions, remember, f of x is the same as y. Right, so if f of x equals x squared plus 2x, find the value of f of x when x equals negative 4. So what that means is, excuse me, replace x, everywhere you see an x, replace it with negative 4. So f of negative 4 equals, now I replaced x with negative 4. Make sure you put it inside parentheses because we want to square the whole negative 4. Not just the 4, but the negative 4. If you don't write the negative 4 in parentheses, then the 2 is only applying to the 4, not the negative 4. And if you do it on your calculator, you'll get the wrong answer. So be clear to put the negative inside the parentheses with the 4. So negative 4 squared plus 2 times negative 4. And then work that out either on your calculator or by hand. Negative 4 squared is 16. It's positive 16. And then 2 times negative 4 is negative 8, so we'll simply write minus 8. And 16 minus 8 is 8. And you can just write it f of negative 4 equals 8. Don't divide by negative 4 on both sides. It's simply saying that we have a function f, and we're replacing x with negative 4. Here's a second example. Remember, try to always pause the video and work it out, and then come back when you're ready. Okay, so here's our function. This time we're going to replace x with 3. So 3 plus 4 in the numerator, 2 times 3 in the denominator. And the numerator will be 7, and the denominator will be 6. You could leave it as an improper fraction. If you want to change it to a mixed number, you can, but it's fine as an improper fraction. Okay, our next slide. We're going to talk about the domain now. Domains of functions. The domain is the set of all x coordinates of a function, and the range is all the y values of a function. How to find the domain? So to find the domain of a function in equation form, we have to notice what values can legally replace x. So for this course, what we're going to be talking about is there's two kinds of illegal replacements. And the first one is it is illegal to replace x with any value that would cause division by 0. This expression used in this case is called undefined. For example, if you write 7 over 0, 7 over 0 is undefined. Some people say 0, but that's wrong. You could even do that on your calculator. On your calculator, write 7 divided by 0. The calculator may say undefined, or it may say math error. Maybe some say not possible. Usually they'll say math error. Go ahead and try it. Put in 7 divided by 0. So 7 first, then a division symbol, and then 0, and then hit equals. And that's what you should get, math error, which is undefined. Okay, so that's the first thing we're going to look at, is we don't want it to be undefined. Here's our second illegal replacement. It is illegal to replace x with any value that would cause a square root of a negative number, or a negative radicand for any even indexed radical. We're talking about the 4th root, 6th root, 8th root, 10th root. So remember when we did square roots of a negative number, like square root of -9? We can't have a negative inside the square root. If you put in your calculator, it'll say no real number. You may have learned complex numbers. In complex form, it would be 3i. Square root of -9 is 3i. That's called an imaginary or a complex number. Okay, but we're only going to be talking about real numbers, so we cannot have a negative underneath a square root. We could have a negative underneath a cube root, but not a square root. All right, domains of linear functions. The last video we did, we talked about linear functions. So far on this video, we haven't talked about any linear functions. We do know it's in the form of f of x equals ax plus b. For example, f of x equals 2x plus 7. That's a linear function. Okay, so when evaluating a linear function using any real number for x, the result will always be a real number. Right? So for example, let's say we have f of x equals 5x minus 3. If you put in any number, what would you get? Let's say you plug in 2. 5 times 2 is 10. 10 minus 3 is 7. We're going to get a real number. Okay, so I didn't finish reading this. Therefore, the domain of any linear function is all real numbers. That's the phrase we want to write, all real numbers. Now there is a notation, a shorthand for it, and it's a capital R. So I wrote down that one. You can write just R, or sometimes you write 2 vertical lines, maybe something like this. So 2 vertical lines and then your R. All right, a little sloppy, sorry about that. So that means all real numbers. Okay, so here in example 3, again, find the domain of f of x equals 5x minus 3. Well, it's a linear function, so the answer is all real numbers. This is a linear function. There's no division present. Division by 0 can't happen. There's no radicals present. So there's not any even index radicals with negative radicands. So there's no illegal substitution here. So the domain is all real numbers. You could write it with that capital R. Again, you could use the 2 vertical lines. and then make your r. Or you could write it in interval notation, negative infinity to infinity with parentheses around both sides. Infinity never has brackets, it's always parentheses. Okay, domains of polynomial functions. When evaluating a polynomial function using any real number, again, the result will always be a real number. This will get more interesting in a little bit, but there's no work to do. Anytime you have a polynomial function, the answer will be all real numbers. Here's an example. This is a polynomial, negative 3x squared plus 2x minus 5. This polynomial is written in descending order from highest degree term to lowest degree term. It doesn't matter what number you plug in, a 5 or a 2. You're not going to get 0 in the denominator because there is no denominator. And you're not going to get a negative in the radical because there is no radical. So there's no square root, we don't have to worry about that. There's no x in the denominator, we don't have to worry about that. So the answer is simply all real numbers. Okay, so we talked about linear functions, we talked about polynomial functions, and now we're going to talk about rational functions. A rational function is a fraction. Specifically, this fraction has a variable in the denominator. So reading this, a rational function is a fraction. This fraction has a polynomial in the denominator. It is not just a constant, so it can't be just a number like 7. There has to be an x in the denominator, an x or an x squared or an x cubed. There may or may not be an x in the numerator. So in the numerator, you could have just a number like 3. But it could have an x or an x squared or an x cubed, and that would be a rational function. So here's our example of a rational function. Again, rational is another name for fraction. So we were talking about fractions earlier, and remember that the denominator cannot be 0. Division by 0 is undefined. What value for x would make this rational function undefined? So what we're asking is, what number would we replace for x that would make the denominator equal to 0? So what number minus 5 equals 0? Right, 5. 5 minus 5 is 0. So it's not defined when x equals 5. Now you may be thinking, well, what about the numerator? What if the numerator is equal to 0? Well, that's okay. If the numerator is 0, it's equal to 0. So if you have 0 over, let's say, 7, I'm just making up a number, that's equal to 0. But if it's the other way around, if it's 7 over 0, that's equal to undefined. Okay, so the function is not defined when x is 5. That's the only number that would make it undefined is 5. Not 8, 8 minus 5 is 3, not negative 2, not any other number, just 5. So here's our procedure. To find the domain of a rational function, again, rational means there has to be an x in the denominator. Number 1, set the denominator equal to 0 and solve the equation. Number 2, write all real numbers except the numbers that you obtained in step 1. Or you could write a shorthand, the capital R, comma, x not equal to whatever numbers you got in step 1. There may be 1 or 2 or even 3 numbers. We'll do some examples. Okay, here's our example. Find the domain of f of x equals 10 over 5x plus 2. This is a rational function. It's rational because the denominator has an x. So since it's a rational function, our procedure is to set the denominator equal to 0 and solve. So we need to determine if there are any values of x that will cause division by 0. And then we're going to exclude these values from the domain. Set the denominator equal to 0 and solve. So we don't care about the numerator. The numerator can be 0. If it's 0 on top, that's fine. We just cannot have 0 in the denominator. So set the denominator equal to 0. So 5x plus 2 equals 0. Then solve that, subtract 2 on both sides. And then divide by 5 on both sides. It does not reduce. On the right-hand side, the 5's cancel out on the left-hand side. So we get x equals negative 2/5. So we're halfway there. Some people stop there and think, great, I solved it. But you have to write our final statement. So we're going to write all real numbers. I use that capital R. You can use the words all real numbers. Except, so you could write the words except x equals negative 2/5, or you could put x not equals to negative 2/5. I put the D there just to say it's the domain. If you don't write the D there for domain, that's okay also. But you definitely have to write the all real numbers, whether in using words or the shorthand symbol, and then x cannot equal negative 2/5. That's saying it could be everything else except for that number. X could be negative 5, 100, 38, 1,000. It could be all the numbers. 2/3. It just can't be negative 2/5. Okay, here's our next example. You might want to pause and do it on your own. All right, so same idea, just set the denominator equal to 0. The numerator we do not care about. The numerator could be anything. We still don't worry about it. Just the denominator. Okay, add 7 to both sides. And then divide by 2 on both sides. And we're all done. Almost. All real numbers. X cannot equal 7/2. All right, find the domain of f of x equals 3x minus 4 over 2x squared minus 5x minus 12. Again, this is a rational function. It's rational because there is an x in the denominator. So we're going to set the denominator equal to 0 and solve. Whatever we get, we have to exclude those numbers from the domain. The numerator we don't have to worry about. If we get 0 in the numerator, that's equal to 0. 0 in the denominator is undefined. Okay, so 2x squared minus 5x minus 12 equals 0. What do we need to do? Right, we need a factor. There's different techniques for factoring. I tend to show factoring by grouping a lot. If you use a box method or some kind of X, or maybe you just do it in your head, that's fine. I'm going to show the grouping method. So for grouping, we multiply the first number and the last number. So that's negative 24, because it's a positive 2 and a negative 12. Then we list the products. Because it's a negative 24, we're looking for the pair that subtracts to be 5. So the products of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which pair will subtract to be 5? Right, 3 and 8. And then we want to insert signs so that its sum is equal to negative 5. So which one's negative and which one's positive? Right, the 8 is negative and the 3 is positive. Positive 3 and a negative 8 will equal a negative 5 when you add them together. They also have to multiply to be negative 24. So that's why one has to be positive and one has to be negative to multiply to equal negative 24. All right, so now you replace the middle term with those two numbers as variable terms. It doesn't matter which one you put first. You could put the 8x first or the 3x, as long as the 3 is positive and the 8 is negative. Now you factor by grouping. Factor an x from the first pair, the way I wrote it, and a negative 4 from the second pair. So x from the first pair gives you 2x plus 3, and then negative 4 from the second pair will also give you 2x plus 3. Those have to match. So now we have 2x plus 3 times x minus 4 equals 0. Set them both equal to 0, so we're going to get two answers this time. And then solve each of those equations. So on the left, subtract 3 on both sides, and then divide by 2. So on the left, we get x equals negative 3 halves. On the right, add 4 to both sides. And then that's all there is to do there. So we got two answers. Negative 3 halves and positive 4. Are we done? No, right? We have to write all real numbers except x equals those values. Or you could use the shorthand. So I use the shorthand. All real numbers, x cannot equal negative 3 halves, and x cannot equal 4. All right, here's another rational function, 8x over 4x squared minus 9. By the way, just to get off track a little bit, we're talking about these functions and talking about the domain. Later on, we're going to talk about how to graph these kind of functions. So knowing the domain is going to be really important for how to graph a function of this type. Sometimes we wonder, like, why are we doing this? And it comes up later on in math classes. And then as far as applications, yeah, it comes up later on too, but it takes a while to get to those applications. So it seems like, what? Why are we doing this? But there's always a reason. All right. Same procedure, set the denominator equal to 0 and solve for x, and this value or values will be excluded from the domain. 4x squared minus 9 equals 0. We have to factor again. Do you remember how to factor that? Let's see, it's a difference. There's a minus in the middle. There's two terms. And both of them are perfect squares. 4x squared is a perfect square, and 9 is also a perfect square. Right. This is a difference of two squares. A squared minus b squared is a minus b times a plus b. It doesn't matter which one you put first. You can put the a minus b first or the a plus b. All right, so this factors to 2x plus 3 times 2x minus 3. So it's 2x because 2x times 2x is 4x squared. That's the square root of the first term. And then the square root of 9 is 3. So it's plus 3 and minus 3. All right, now set them both equal to 0 and solve. Okay, and the one on the left, subtract 3 on both sides. Then divide by 2. If I go too fast, you could always pause the video and work it out on your own. So we get negative 3 halves on the right, on the left, and on the right, same thing, add 3 this time. And then divide by 2, so you get 3 halves. So don't forget to finish it off. You got to write the all real numbers. X cannot equal negative 3 halves, and x cannot equal positive 3 halves. If you don't write that last line, you're not going to get full credit. So you want to get full credit, right? Okay, another rational function. Find the domain of f of x equals 3x squared minus 12 over x squared plus 4. Set the denominator equal to 0. Again, the numerator does factor, but we don't care about the numerator. All we care about is the denominator. So set it equal to 0, and then whatever values we get must be excluded from the domain. So which one's the denominator at the bottom? X squared plus 4. Now, does that factor? Let's see, x squared and 4 are both perfect squares, right? X times x is x squared. 2 times 2 is 4. But is it the difference of two squares? No, right? Because it's a plus in the middle. The sum of two squares is not factorable. So there's nothing that works to factor that. So therefore, there's no answer we could get. So the domain is simply all real numbers. You can write it in words or with the symbol, that capital R. That's it. All right, let's move on to domains of square root functions. So we're talking about square root functions. A square root, the index is a 2. We usually don't write the index when it's a 2. It's assumed to be 2. So we cannot have a negative number in a square root. Right? The square root of a negative number is not a real number. So if you try to type in the square root of, let's say, negative 9, it's going to say math error, or maybe just error, or not a real number. Depends on your calculator, what it's programmed to say. Now, if some calculators, you can change it to complex mode, and then it'll give you 3i. But that's not in the real number system. Okay. Yeah, so that's what I wrote. It is called an imaginary or a complex number, but we're not talking about complex numbers here or imaginary numbers here. Okay, so here's our procedure. And actually, this is for square root functions or any even root function. So a square root, that's a square root, right? Another even root would be if there's a 4 here, or maybe a 6 here. Those are even root functions. So the procedure is number 1, set the radicand greater than or equal to 0, and then solve the inequality. The radicand is what's inside. So that whatever's underneath that radical symbol, that is the radicand. Then we're going to write the solution in interval notation. All right, here's our first example. Hang in there, we're almost done. Just 2 more problems. Find the domain of f of x equals square root of x. So our procedure is we're going to write the radicand greater than or equal to 0. So on the last examples, we were talking about rational functions. That one we put equal to 0. This one we put greater than or equal to 0. And then we're going to solve the inequality. So in this case, it's simply x. X is greater than or equal to 0. Is there anything to do to get x by itself? No, x is already by itself. So now we're going to write that in interval notation. I kind of like to graph it first. You don't have to. It doesn't say to graph. So x greater than or equal to 0, which way would we shade it? To the left or the right from 0? Right, to the right. And then brackets or parentheses. Yeah, it's got the equal, so brackets. And infinity is on the right. So the way we would write this is brackets 0, comma, infinity. All right, last problem here. Find the domain. F of x equals 2x minus 5 underneath the square root. So write the radicand greater than or equal to 0. Now we're going to solve the inequality. Add 5 to both sides. Then divide by 2. So x is greater than or equal to 5 halves. Don't forget that if we do have to divide by a negative, then you have to flip the inequality symbol around. So that doesn't happen on this example, but maybe in the homework it does. So don't forget about that. Whenever you divide by a negative, you have to flip the inequality sign around. Okay, so let's put 5 halves on a number line. Again, we're going to shade to the right and use brackets. So this one would be 5 halves to infinity. All right, that was it. I'll see you here for the next video. Have a good day.